Hey guys, welcome back. It's your favorite time in geometry. It's time to do some constructions. Chapter 7, the constructions that you're required to do are 45-degree angle, a 90-degree angle, a 135-degree angle, and construct a square given a side length. So I'm actually going to start with a square given a side length. So let's get started. Okay, so this is a square. So go ahead and start with a side length. Let's call it AB. And we want to use this segment actually is going to be part of our square. I'm going to use that as the bottom of my square. I want to create a perpendicular through point B, which is going to be the right side of my square, and so my square is going to kind of be like that. Okay. So to create a perpendicular through this point, okay, normally we would just put our compass on that point, but we need a little bit more room over here. So I'm going to, first thing is I'm going to extend this. And it doesn't matter how far, you just need some space. Okay, and then what I'm going to do is go ahead and open up my compass to a medium setting, place it on point B, strike an arc on both sides of B, and you could just make it a big smiley face if you wanted to, but I just made 2 arcs. Now open up your compass a little bit more, doesn't matter how much, but the compass has to go past point B, past halfway. Strike an arc above B, strike another arc above B. There's your perpendicular. Make sure you make your perpendicular nice and long on this side. It doesn't matter if you stop at B or go through it, it really doesn't matter. So now I have the bottom of my square and the right side of my square. This last part, you guys are going to love this. This last part is super cool because all I have to do is open up my compass to the given side length from A to B, and I don't have to do anything more with the compass setting. Now I simply chop off how much of this I want right up here and move your compass over to point A and make that same arc. So to me these kind of look like eyebrows, so you make your eyebrows. And then, with the same compass setting, okay, put your compass on this intersection point and strike an arc this way. Now, does anyone see the square? It's this intersection point to point A, and then this intersection point to this intersection point. And there's your square. Super cool. All right. So this also shows you that you could actually use this method to just make a 90-degree angle. Okay? And that was one of the things we were asked to do, was to make a 90, a 45, and a 135. So if you wanted to just do this, you could do that and make your 90-degree angle. And then if you wanted to make a 45, you could simply bisect this angle. I'm going to show you a couple cool things, a couple different ways to do a 90 and a 45. Okay, so a 90-degree angle. Go ahead and start with a ray or a line segment. It doesn't really matter. We're going to make a 90-degree angle right here. And the way we're going to do this is actually through our study of circles, which we haven't learned yet. Circles is going to come in chapter 10. But when you study chapter 10 in circles, you're going to learn a really cool thing called Thales' theorem. And this construction is based off of Thales' theorem. Go ahead and open up your compass. Well, let's draw a point. We need another point that's not on the circle. Okay, that's up here, somehow inside. You don't want it straight above, you want it like, I don't know, maybe like that. Okay, and I should probably do some labels. Let's call this point A. Let's call this point B. So just open up your compass from A to B. Okay, and put your compass on B. And just strike a really long arc that goes all the way through and going all the way around. You could actually complete the circle if you wanted to. That's fine. But you see this point of intersection right here? Okay, I'm going to call that point C. Go ahead and put your straight edge on point C and B and draw that line segment. That line segment would be a diameter of this circle, which I didn't complete the circle. You can complete the circle, but it would be the diameter of that circle. Thales' theorem tells us that this angle right here is going to be a right angle. And what's really amazing is that if I moved point A anywhere around here, it would always be a right angle. More on that later in chapter 10 when we get to study that. Okay. Then what you could do is just go ahead and bisect this angle, and you would have your 45-degree angle. Okay. And then you could simply use linear pairs to get your 135, or you could use angle addition. Let me show you another way to construct a 45-degree angle, and this is going to be based off of what is called special right triangles. Okay, so let me just scooch it up here. I'll use the bottom part of this paper. So let's go ahead and start with some line segment. Okay, and let's make a perpendicular bisector of this thing. Okay, so to do that, I just open up my compass a little bit more than halfway. And I call that the football. So let's call that point A, point B. Okay, so here is my perpendicular bisector. Now, if I look at this point to this point, let's call this point C. If I go from point A to point C, right there, I know that this is a 90-degree angle. So if I chop that right up there, and I look at this intersection point, right here where I chop that off, I know that this segment is congruent to this segment. If I call that D, I know that AC, segment AC, is congruent to segment DC. Okay, so if I simply connect these, you see the triangle ACD? What kind of triangle is that? It's a right triangle, but I also know that this segment is congruent to that segment. This is called a special right triangle, also known, this particular special right triangle is known as a 45-45-90. We know that if this is 90 degrees, there's a corollary we learned that these two acute angles must be complementary. They must add up to, their measures add up to 90 degrees, but they're also congruent because base angles theorem. So that means that that is a 45-degree angle. And by the way, I'm not going to do the 135 because the 135 is, let's think about the linear pair. Here's your 135 right there. So if you're asked to construct a 135-degree angle, I would construct a 45. However you want to do it, construct a 45 and then just use its linear pair. Thanks guys. See you in the next video.